Hello and welcome to this new video tutorial of DataMonk, and in this video we will be discussing about decision trees. Okay, so in the previous video I discussed about what is classification, what is regression, what are the different ways of doing classification, what are the different ways of doing regression. Okay, so in this video we will be discussing about decision trees, which majorly comes in the category of regression, but it can also come in the category of classification. Okay, so if you haven't checked out the previous videos in which I talked about machine learning and what is artificial intelligence, okay, and what are the different algorithms used in machine learning and artificial intelligence, you can just go and check the previous two videos which I've created. And if you want an in-depth knowledge and how we can do coding and how we can write different algorithms in Python, then there is a playlist available on DataMonk. So you just have to write the name of the algorithm which you want to see, which code you want to see, and then just type datamonk in front of it and search it on YouTube, and you will be able to get it. Okay, so what is decision trees? Now, a tree has many analogies in real life, and turns out that it has influenced a wide area of machine learning, covering both classification and regression. As I said, that decision trees can come under both classification and regression. Okay, so in decision analysis, a decision tree can be used to visually and explicitly represent decisions and decision making. As the name goes, it uses a tree like model. So why, you can ask that, why decision trees are called decision trees? Because it looks like a tree. Okay, you will see, when you'll see the model, you'll see that the visual representation looks like a tree. So though a commonly used tool in data mining for deriving strategy to reach a particular goal, it's also widely used in machine learning, which will be the main focus of this video. Okay, so how can an algorithm be represented as a tree? Okay, how can an algorithm look like a tree? For this, let's consider a very basic example that uses Titanic dataset for predicting whether a passenger will survive or not. Okay, so this is a very famous dataset, and you will be able to get this dataset on Kaggle. So if you go and search on Kaggle about Titanic dataset, then you will be able to get this dataset very easily. It's very famous also. So this Titanic dataset is basically used for predicting whether a passenger will survive or not, given different categories, or given many features and categories. Okay, so below model uses three features and features, we also say attributes or columns from the data set, namely age, sex, and number of spouses or children along. So we have represented it by SIBSP. Okay, SIBSP. So this is a variable which we have taken, and it basically means number of spouses or children along. Okay, so if you're familiar with the Titanic dataset, or even if you're not familiar with the Titanic dataset, if you will see the dataset, then there are many features. Okay, there are many dependent variables, as you say. There is one dependent variable where whether he'll survive or not, and there are many independent variables. So the independent variables being sex, age, and number of spouses or children along. Okay, so these variables basically, it decides that whether the person will survive or not in the Titanic data set. Okay, so the very first question is that, is the sex male, yes or no? Okay, so if the sex is male, then the chances, then again it will go to the next criteria, that what is the age? Okay, what is the age? So if the sex is not male, if the sex is not male, then then there's a chance that he survived. Okay, then there's a chance that he survived. And if the sex is male, then we will see that what is his age. Okay, if the age is less than 9.5, then there's a chance, that 61% chance that he died. Okay, and if the age is greater than 25, okay, is if the age is greater than sorry, if the SIBSP is the number of spouses or children. Okay, so if the age is greater than 9.5, then there's a chances that he died. And if it is less than 9.5, then what happens? We see that how many siblings or spouses or children is he carrying. Okay, then there's a chances of death and survival. And over here, if he is not male, he will survive. So this is just for the representation. Okay, we need not go into the depth of this particular data set to understand decision tree. This is just used for representation, that how the model of decision tree looks like. Okay, so moving on, A decision tree is drawn upside down with its root at the top, okay, with its root at the top. So the root in this particular data set is that the sex of is whether the sex is male or not. So basically the root is the gender, okay. In the image on the left, the bold text in the black represents internal node based on which the tree splits into branches or edges. The end of the branch that doesn't split anymore is the leaf. In this case, whether the passenger died or survived represented as red and green text respectively. So, what are leaves and what is root? Okay, so decision tree is known as decision tree because the features are just like a tree. Okay, so in the tree, what happens that we have root. So similarly, in this model also we have root, but the root is at the topmost position. And in this case, the root is that what is the gender? Okay, what is the gender? So whether the gender is male or not, that is the root, okay. And then what are the leaves? This red boxes or this green boxes, this is basically known as the leaf, okay. And what happens, what is one feature of the leaf? That it does not split anymore, okay. We can see that there are no more branches, we can see that there are no more branches from this died or survived, so it does not get split anymore. Now, although a real data set will have a lot more features, obviously, as we see in data, if you go to kaggle.com and if you check out any data set, then you will be able to see that in those data sets, there are many independent variables with which ultimately form that what the dependent variable will be. So in the real data set, we'll have a lot more features, and this will just be a branch in much bigger tree, but we can ignore for simplicity in this particular algorithm. So the featured importance is clear and relations can be viewed easily. Okay. So this methodology is more commonly known as learning tree from data, and above tree is classification tree, as the target is to classify passengers survived or died. Okay, so this is a difference between classification and regression tree. We are basically classifying whether he survived or he died based on many factors. So that is why this is known as a classification tree. Okay, that is why this is known as a classification tree. Okay, but what is a regression tree? So regression trees are represented in the same manner, just they predict continuous values like price of a house. Okay, so in the previous two videos I discussed about the example of the price of the house. Okay, what will be the price of a house based on the features of the house and based on the data on which the model is trained. Okay, so similarly in regression trees, the values like the price of the house, etc., it comes in the regression trees. In general, decision tree algorithms are referred to as CART or classification and regression trees. Okay, so together it is known as CART, classification and regression trees. Now, so what is actually going on in the background? You may ask, okay, what is actually going on in the background? So, growing a tree involves deciding on which features to choose and what conditions to use for splitting. Okay, along with knowing when to stop. Obviously, when we grow a tree, the branches split and then we have the leaves do not split. So why, where, who is deciding that what will be the conditions on which it will split? Okay, when to stop, who will decide all those? Okay, so as a tree generally grows arbitrarily, you need to trim it down for it to look beautiful. Okay, so let's start with a common technique used for splitting. Okay, so we'll be discussing about different techniques over here which we use for splitting. Okay, so I'm just giving a zest, just giving an introduction of these different splitting techniques, and you can actually write lines of code for splitting. Okay, when you get a data set, okay, you will go to Jupyter Notebook, you'll go to Python, and actually you can write lines of code for, given your data, you will have to split it. Okay, you'll have to split it, you will have to see the cost of splitting, you will have to train your model. So everything you can do it, and for those we have videos created. So this is just for your understanding the theoretical part, that what an actual decision tree is, obviously, because when you will go to interviews, you will not always be asked about, the coding part. They'll also ask you the zest of it, or what do you understand from it. So this video is basically made for your understanding. Okay, so recursive binary splitting is one such technique of splitting. Okay, So in this procedure, all the features are considered and different split points are tried and tested using a cost function. So the split with the best cost or the lowest cost is selected. Okay. So consider the earlier example of tree learned from the Titanic dataset. Let's see the earlier example. So in the first split or the root, all the attributes features are considered and the training data is divided into groups based on this split. Okay. So we have three features. We will have three candidate splits. Now we will calculate how much accuracy each split will cost us using a function. The split that costs least is chosen. Okay, so the split which is costing you the least, that split will be chosen ultimately. Okay, which is our example is the gender of the passenger. This algorithm is recursive in nature as the groups formed can be subdivided using the same strategy. Due to this procedure, this algorithm is also known as a greedy algorithm as we have an excessive desire of lowering the cost. Okay, so what is cost? What is lowering the cost? When we split the data set, okay, when we split the data set, we'll generally try to divide the data set in such a way that the cost is minimized. The cost of dividing the data set is minimized. Okay, and so that will become the root. Okay, that will become the root. So root is generally decided on that way, in that way. So this makes the root node as the best predictor and classifier. Okay, so in this case there are different types of people on the Titanic ship. Okay, there were different kinds of people on the Titanic ship, but the major two categories in which the people can be divided were that whether they are men or they are female, whether they are male or female. Okay, so these were the basic broad two categories in which they can be divided. So that gender thing becomes our root. Okay, because there are other categories in which they can be divided, but then the divisions will be more. The basic broad categories is their gender. Okay, now coming to the cost of split. Just a second. Yes. So let's take a closer look at the cost functions used for classification and regression. Okay. In both cases, the cost functions try to find the most homogeneous branches or branches having groups with similar responses. This makes sense. We can be more sure that the test data input will follow a certain path. Okay. So there are various cost functions which is used for measuring the cost. So the very first is sum and in the bracket y minus prediction to the power 2. So let's say we are predicting the price of the houses. Okay. Now the decision tree will start splitting by considering each feature in the training data. The mean of the responses of the training data inputs of particular group is considered as prediction for that group. Okay. So the above function is applied. This function we are talking about, this is applied to all data points and cost is calculated for all candidate splits. Again, the split with the lowest cost is chosen. Okay. So this happens. This one is used when we are doing regression. Okay. Then when we are doing classification, then we use this function. Okay. When we are doing classification, we will be using this function. Now, this is known as a Gini score. Okay. So a Gini score gives an idea of how good a split is by how mixed the response classes are in the groups. Okay, so here pk is proportion, this pk we are talking about, so this pk is proportion of class inputs present in a particular group. Okay, a perfect class purity occurs when a group contains all inputs from the same class, in which case pk is either 1 or 0, g is equal to 0, where as a node having 50-50 split of classes in a group has the worst purity. So with the binary classification, it will have pk is equal to 0.5 and g is equal to 0.5. Okay, so okay, now when to stop splitting. Okay, so as a tree cannot divide and divide and divide itself, it cannot continuously divide itself, it will have to stop somewhere, isn't it? It will have to stop in the leaves. Similarly, this decision tree will also have to stop splitting itself, it will also have to stop splitting the data. Now You might ask that when to stop growing a tree. Okay, when to stop growing a tree. So as a problem usually has large set of features, it results in large number of split, which in turn gives huge trees. Such trees are complex and lead to overfitting. Now in this is a very important concept, this is a very important concept of overfitting and underfitting. Okay, so if we try to overfit a model in a data, then what will happen? We'll miss the zest. Okay, we'll miss the main point of the data. And if we try to underfit, then the results will not be accurate. Okay, so overfitting and underfitting is a very it's a very important concept. It's a very important concept in statistics. Okay, so moving on, moving on, we do not want to overfit, so we need to know when to stop. One way of doing this is to set a minimum number of training inputs to use on each leaf. For example, we can use a minimum of 10 passengers to reach a decision. Okay, we can use a minimum of 10 passengers to reach a decision and ignore any leaf that takes less than 10 passengers. Another way is to set maximum depth of our model. Maximum depth refers to the length of the longest path from the root to a leaf. Okay, and then we have something known as pruning. Okay, so what is pruning? The performance of a tree can be further increased by pruning. It involves removing the branches that make use of features having low importance. So in a data set, we have different kinds of data. Okay, and most and see, we majorly collect data which are important, but we also have to collect data which are not very important. Okay, in when we are making a regression table, okay, we also collect data which is of not much significance. Okay, so in that case, removing the branches that make use of features having less importance, we remove the branches which uses the features which has less importance. This way we reduce the complexity of a tree and thus increasing its predictive power by reducing overfitting. Okay, now, pruning can start at either root or the leaves. The simplest method of pruning starts at the leaves and removes each node with most popular class in that leaf. This change is kept if it doesn't deteriorate accuracy. It's also called reduced error pruning. Okay. More sophisticated pruning methods is known as cost complexity pruning, where a learning parameter alpha is used to weight whether the nodes can be removed based on the size of the subtree. This is also known as the weakest link pruning. Okay, so we learned about reduced error pruning and we learned about cost complexity pruning and the weakest link pruning. Okay, now advantages of CART or classification and regression trees. Okay, so it is simple to understand and it is very important to visual, it is very simple to visualize. It just looks just like a tree, so it is simple to understand, interpret and visualize. Decision trees implicitly perform variable screening or feature selection. It can handle both numerical and categorical data. Okay, so it's very important as we see in our when we make regression tables. Okay, we have to give only numerical data, we have to give only numerical data in the form of numbers. If even if we have got categorical data, we'll have to change it into numerical data. So let's say that we have got responses like yes or no, so we'll have to give 1 for yes, 0 for no, or vice versa, and then we will have to use it in a regression model. Okay, so and this is a problem with regression which can be solved using decision tree because it can handle both numerical and categorical data. It can also handle multi output programs. Okay, decision trees require relatively little effort from the users for data preparation. Okay, data preparation, we do not have to do much data preparation, we do not have to convert every yes or no to zeros and ones and every binary values to numerical values, because it can handle the categorical data as well. So non-linear relationship between parameters do not affect tree performance. Okay, and there are some disadvantages also, nothing comes for free. All right, so there are some disadvantages. So what are the disadvantages? Decision tree learners can create over complex trees that do not generalize the data well. This is called overfitting. So suppose that we have data about, we have many features in a data. Okay, we have many columns of data, and a data scientist or it creates a decision trees involving all those data, then the tree will become huge. Okay, there will be many branches, and it will be a classic case of overfitting, which we do not want. Okay, which we do not want. So that is why decision trees can be a little complex. Now, decision trees can be unstable because small variations in the data might result in a completely different tree being generated. This is called variance, which needs to be lowered by methods like bagging and boosting. Now, greedy algorithms cannot guarantee to return the globally optimal decision tree. This can be mitigated by training multiple trees, where the features and samples are randomly sampled with replacement. And decision tree learners create biased trees if some classes dominate. It is therefore recommended to balance the dataset prior to fitting it with a decision tree. Okay, so these are the cons. Now, this is all the basic which we talked about. This is all the basic which we talked about in this video to get you at par with decision tree learning. Okay, an improvement over decision tree learning is made using technique of boosting. Okay, a popular library for implementing this is scikit-learn. Okay, scikit-learn is very important. It's an important library in Python. So if you learn about scikit-learn, you will be able to understand decision tree better. And Datamonk has a video on scikit-learn. Okay, and it has wonderful API that can get your model up and running with just few lines of code in Python. Okay, so we can code everything which we talked about over here. Okay, everything which we talked about over here, starting from splitting, when to stop splitting, the cost of splitting. Okay, and what type of tree based on classification or based on regression, everything which we talked about right now in this video can be implemented with the help of Python. It can be implemented on a data set, and we can find valuable insights. Okay, so this was all about decision tree. This was just the introduction. This is the basic zest of decision tree, and you can check out other videos in which you will be able to learn about how we can actually write the lines of code in Jupyter Notebook using a data set, and how we can implement what we have learned over here. So we'll see you again in the next video, and we'll cover some introduction of some more important ML algorithms.